Alright, this is lesson 32 for Algebra 1, Graphing Linear Inequalities. Okay, the objective, we're going to graph inequalities that are linear. So linear stands for, the key word is line. We're graphing lines, but they're inequalities. So we're saying things are more than, less than, or equal to the line. Okay, and so yesterday, and up until now, we've talked about functions and how we had like an x and y axis. Let's say we were to graph a line. Let's say this was the y-intercept, and there were some points, right? We talked about how yesterday it's a lot easier for us to have graph a line, because then we could easily see the points, okay? But sometimes we could talk about how points could be, answers could also be less than, which means the answers could be underneath the line and on the line, or they could be above the line or greater than, or they could be not part of the line, which meaning it's just not equal to the line, but it could be not equal to the line but below the line. So we're going to talk about that. So making the equations true. Okay, so we use graphs like before to make it easier to understand the math function. Okay, math machine. All right. So here we go. These are the steps. Same as yesterday, you got to make sure it's in y-intercept form, and you're going to plot the y-intercept, plot 2 points, draw the line, and then the line needs to be solid if it includes the equal sign. If there's no equal sign, then we leave it dashed, and then we shade above the line if it's greater than, and below the line if it's less than. So, okay, here we go. Numbers 1 and 2, watch carefully. All eyes up here. This is like yesterday, it's just one more extra step. So, first thing you want to do is make sure it's in slope-intercept form. It looks like it is. So we have y is less than or equal to 2/5 x. So this looks like it's good. We have a slope right here of 2/5 plus 1. That's our y-intercept. So it's all in the right form. So our y-intercept is 1. So we're going to go to 1, draw a point. Then our slope is 2/5. So we're rising 2, running 5. Okay, eyes up here, eyes up here. We're rising 2, running 5, 1, 2, 3, 4, 5. So there should be a point here. There should also be a point continuing all the way out here, but we don't have enough graph paper, so we're going to go the opposite way. Rise opposite way, run the opposite way. There's a point here. Okay. Now I'm going to draw a line, okay? And since our graph has the less than or equal to, it specifically has equal to, we're going to draw a straight solid line. Oh, try that again. Okay, and we have a straight solid line, and we want to make sure it stays solid. And then we look at, what does it say? It says less than or equal to. So we want to shade underneath it. So we would take a highlighter, or you would shade with the side of your pencil. Okay, I'm going to use this color right here, and I'm shading less than because it says less than, okay, right underneath it. Okay, so what this is saying is that I could pick any point in the shaded region or on the line, and it would make my equation true. It would be part of the solution, okay, which means I could pick any of these ingredients, and any of the outputs in those ingredients would work, okay? All right. Number 2, watch me do number 2 one more time. Number 2 is not in slope-intercept form, so we need it so it's y is equal to. Y is not by itself, so we need y to be by itself. So the first thing I'm going to do is subtract 4x on both sides. So we're subtracting 4x on both sides. When we do that, we get, I'm going to move this up here actually, 3y. 3y is less than negative 4x. Minus 3, dividing both sides by 3, and we get y is less than negative 4/3 x. Negative 3 divided by 3 is negative 1, okay? So this is really our equation here. So now I'm going to plot my y-intercept of negative 1. We said that there's a negative slope, so it's going down negative 4 and running 3, so there should be a point here. Can't go negative 4 this way, so I'm going to go the opposite way on the first point. Going the opposite of negative 4, running the opposite way. And we got some points here. Now on this one, This one is not equal to. So since this is the case, we're going to draw a dashed line. Okay, so on this one we notice that it says less than. Okay, so it's not equal to. So I have to draw a dashed line. When I do that, it's going to look something like this. Okay, draw some arrows at the end. Okay, and we said this one's less than also, so I'm going to take my marker or the side of my pencil and shade underneath it. And what this is saying is at any point not on the line but below the line would be an answer to this equation. Okay, that's it. That's all we're doing. This is the point of today's lesson, is graphing. So you're still graphing lines. The only difference is you have to ask yourself, is it shaded or is it dashed or not? And then where is it shaded, above or below? Okay, that's the only thing we're adding today. All right. Any questions? Raise your hand if you've seen this before. Okay, good. So, I'd like you to do is 1 still 2 is about number 1, 2 still 1 is about number 2. Ready, set, go. So on number 3, we have y is greater than negative 3 halves x plus 2. Okay, so looking at number 3, what is what's the y-intercept? 2. Okay, so everyone's pulling up the graph axes background. So we're going up to 2 on the y-intercept and plotting a point there, okay? What's our slope on this one? Good, negative 3 over 2. So it's like saying negative 3 over positive 2. Or I would expect you to do that, okay? So if it's negative, we know that we have a line that's going to look like it's going downhill, right? Not uphill. So if yours starts going uphill, you're doing it wrong, okay? So from this point here, we're going to go down 3, run 2, should be a point here. Again, down 3, run 2, point here. And in the opposite direction as well. Up 3, run 2 the opposite way. Okay? So my points look like they're in a straight line just like yesterday. Okay? Now, is my line going to be solid or dashed? What do y'all think? Dashed. Why is it dashed? Good. It doesn't have an equal to sign. So we're going to take our line and we're going to draw a dashed line through all our points using a straight edge. Okay. And draw arrows at the end because we know that this dashed line would go to forever. Okay. And now I have a question for you. Should we shade above or below this line? Does it say greater than or less than on this example, number 3? What? It's above, right? Because it says greater than. So I'm doing this one together with you, so I want to see yours look like mine. Okay, so just finishing it up here, and then I'm going to look around for yours, okay? I'll give you 30 seconds. I want to see yours as well. Okay, so on number 4, what's wrong with number 4 before we even start? Is it in slope-intercept form?
No.
No, so how do we get it into slope? I'm sorry, do not interrupt the class. That was rude of you. Okay, so is it in slope-intercept form? No, so what should we do first? We're going to subtract x, right? I heard someone say that. So we're subtracting x on both sides. Okay, these cancel out, so we get y is greater than or equal to negative x plus 2. Okay? Is it in slope-intercept form now?
Yes.
Good. What's our y-intercept? B is equal to?
2.
M is equal to? Is there an M right there? No. What's the imaginary number in front of the x? Negative 1, right? If it's negative 1, how do we make negative 1 a fraction? Over 1. Is the 1 in the denominator negative or positive? Positive. Positive. Okay. Go. Do this one, please, by yourself. So on this one, again, yours should have looked like this. Y-intercept at 2, and then you're rising negative 1, running 1. So you have a point here, 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 here. Be careful with how you count, okay? Some of you are just doing this, okay? You're like, oh, it looks like it's supposed to be here, and here, and here, and here, and here. And then you're drawing some weird line, okay? That's not what I'm asking, okay? It needs to look nice and neat and precise, okay? So you need to try, okay? Some of you aren't trying. You're like, whatever. I don't care. You should care, okay? Then you have to draw a straight line, okay, and it's solid for this particular example. Draw some arrows at the end, and this one says greater than, so we have to shade above this line, okay? Okay. You would do that with your pencil, okay? Here we go, number 5. Number 5. On number 5, are we in slope-intercept form? No. So what should I do first? Subtract what?
3x.
Okay, we're going to subtract. So what we get now is negative 4y is greater than or equal to negative 3x. Okay. Is y by itself yet still? No. What do I need to do now? What? Divide by what? Negative 4. We're dividing by negative 4. What happens when you divide by negative, everyone? And then you flip the inequality sign. So instead of greater than or equal to, it's going to be less than or equal to 3/4 x. There you go. Here's your form. Is there a y-intercept? No. So what should be there when there's no y-intercept? 0. This is really it right here. Okay? Go. You just have to put the y-intercept at 0, which is just right in the middle right there. That's it. That's your y-intercept, right? And then, just like Rebecca said, you're going to rise 3. Oh boy, I'm sorry. Rise 3, run 1, 2, 3, 4, right? So, that's your hint. Go. Okay, so on this one, you're again, you're rising the opposite way. Right here. And we have a solid line, right? On this particular one. Oh, that wasn't very good. Try that again. So this one is shaded underneath, right? Because it's less than. So you'd shade it underneath this line. That's it, okay? I think we're good. We're all getting it at this point, so we're going to end the lesson there. And I'd like you to turn off your iPads, talk about these questions. Go.